Alright, the next thing we're going to do is we're going to still look at factoring using the distributive property. It's just going to be a little bit different when you have 4 or more terms. You still use the distributive property, but what we call that is factoring by grouping. So anytime you have 4 or more terms, you're going to factor by grouping. Now you're really only going to be dealing with here in Algebra 1 just 4 terms. The way you do that is you just put terms into 2 groups, and then you can factor out GCF. So there's a little key concept here. It shows you if you have AX plus BX plus AY plus BY, if you group the first 2 together, and then if you group the second 2 together, you'll notice that they have something in common. So the first group, they each have, you have an AX plus a BX, they each have an X in common. So if you factor an X out of each of those, you have an A plus a B. In the second group, you notice they each have a Y in common. And if you notice, they each have an A plus a B left over. So what you do for your final answer, notice how your X plus Y is on the outside of your parentheses. You're going to group them into one set of parentheses. And then your A plus a B, you actually have 2 of these, but because it's a GCF, what we're going to do is we're going to write it once. So there's a pattern here. Remember, math is all about patterns, so you want to make sure you read the patterns. If we look at example 3, we're going to group the first 2 terms together, and then we're going to group the last 2 terms together. And you have to make sure you include this negative here. You best be including it. So if we have a 2xy plus 7x, the thing that these two, the 2xy and the 7x have in common, the only thing, 2 and 7 don't have anything in common, so they do have an x in common. So if we factor out an x and divide each of these terms by x, you end up with a 2y plus a 7. Now the reason you include the negative over here is because you have to take out, even though you have a negative 2 and a negative 7, 2 and 7 don't have anything in common. Since they're both negative, you can take out a negative 1. So if we divide each of these terms by a negative 1, you will end up with a positive 2y plus a 7. What do you notice about these 2 terms inside the parentheses? Wait for it. Wait for it. Aha! Yes, they are the same, which is what you want. If they are not the same, then you have done something incorrect. I mean, they have to be exactly the same, identical, twins. Kind of like, right, Bryce? You know what I'm talking about. So what we're going to do here is your final answer, you have one more step to go down. You take whatever's on the outside, x and a minus 1. So if we want to group these 2 together, we're going to say x and a minus 1. If we group those 2 together, we're going to put that in one set of parentheses, x minus 1. And then if you take just one of these sets of parentheses, you get a 2y plus 7. That would be your final solution. Now remember, what is a way that you can check your final solution? Well, the way you can check your final solution is you can always just multiply it back through, FOIL it. So if you start with an x minus 1 times 2y plus 7, and if you want to FOIL this back through, you say, well, x times 2y is 2xy. X times 7 is a 7x. Negative 1 times a 2y is a negative 2y. And then negative 1 times a 7 is a negative 7. What do you notice? Yeah, it's kind of like the same thing as you got up, I don't know, like up here, right there. Same thing, same thing. See that? Right there? Same thing. So you can always check your work if you're not real positive, but you should be getting the same thing. That concludes example 3.